So here are a few example problems for 9.6. Hopefully you've tried them already, and these are going to be the solutions. So for this first one here, we have x, which is located right here. That's our angle x. And we don't really have any arcs measures of angle x because x subtends arc AJ, HJ, and FE, but we know the measures of JE and HF. So we can kind of call this arc here, maybe we'll call this arc Y. And we can find Y because Y subtends 143 and 51. So Y is going to be, using the formula for an angle on the inside of the circle, 143 plus 51, where we're adding these two together, which looks like, what, 194, which I think is going to be 97 degrees. Y doesn't look like 97 degrees. The reason why is because JE is really probably not drawn very particularly well. JE is drawn more like an arc that is much smaller. JE, if it's 143 degrees, probably should be coming out to here. So that's the reason why Y doesn't look like an obtuse angle, even though the measures that we use are saying that it is an obtuse angle. But now we know Y and X. Well, we know Y and X must be supplementary because they are a linear pair. So therefore we can say x plus 97 equals 180, and therefore I believe x is going to be, no, that's not right. Yeah, that is right. Okay. So now let's move on to problem number 2. Problem number 2 has an angle that is outside of the circle. Now, we know that we're going to use a different formula for that, but we're asked to find this x over here, and this x over here, again, doesn't look like we can get there too quickly. We have kind of a middle step that we need to think about. Let's try and think about this arc here. Can we find the measure of this arc, BD, which I'm going to call Y? The answer is yes, because we can use that. We know that the angle on the outside equals 1/2 the larger arc that it subtends, right? The larger arc that it subtends is 166 minus the smaller arc, which is what we just called Y. Cross multiply, we multiply both sides by 2. And then we can add Y to both sides. And then subtract 84 from both sides. And we get Y equals 82. Now, before you walk away from the problem, remember that's not what was asked. We created this Y construct, right? We need to find X. Well, how are we going to find X? Well, we know that X plus 166 plus 82 equals 360. So X is going to be 360 minus 166 and 82 combined. Looks like it's about 248. So I think X is 112 degrees. Okay, and these continue to get challenging, right? We're going to keep on moving through these. Here we have some information. We're asked X, and if you look at me, I'm like, I don't have too much information. Well, I do have an angle here, and the arc that subtends is arc PO. So therefore, I know that arc PO is 46 degrees. That's great. Unfortunately, I don't have enough information because even though I have this, big arc that is subtended by angle M, M is this over here, M is this angle over here, that's the big arc, and here's like the small arc. I don't have enough information. I mean, if I knew angle M, I'd be in good shape. Well, fortunately, I do know angle M because we were given this. We're given the fact that these two sides are congruent, and therefore, if these two sides are congruent, base angles of an isosceles triangle are congruent, and therefore we know that's 23. So now we can say that 23 must equal 1/2 x minus the 46 that we had. Maybe I should have written that in red. So therefore, what does x have to be? Well, 23 equals 1/2 x minus, distribute the 1/2, 23, add it to the other side, 46 equals 1/2 x, multiply both sides by 2, and x equals 92 degrees. Now we come over here, we have another x. This x is going to be on the outside, so we're going to have x equals, right, 1/2 the big arc minus the small arc, right, the larger arc, which in this case is a major arc, right? And we have to think about, well, we don't know this major arc. We know the minor arc's 100. But how are we going to find the major arc? Well, if this whole thing is 360 and this is 100, this must be 260. So therefore x must be 1/2 of 160, which is 80 degrees. Now this problem might look like it's more straightforward, but it could become a lot more challenging if instead of giving this 100 degrees, what if we just were given this? If we were just given this angle measure here, we'd have to then set up an expression for calling this x and this 360 minus x, right? The big one would be 360 minus x. So if these two were reversed, the problem becomes a slightly more challenging algebra problem. I love these kind of problems with multiple parts. Here we have x, right? Well, we can find x first because we see the two arcs that it subtends, right? The first arc that it subtends is over here, it's BE. And then the next arc we have is 80. So we know that x is going to be 1/2 70 plus 80, which is 1/2 of 150, which is 75 degrees. Now to find the next ones, it gets a lot more challenging at least. And the thing that I have to notice is that, well, I'm going to have to come up with some middle steps here because I don't have enough information for y. Y, if I look at y, the arc that it subtends is FG. And I don't know the measure of arc CG, so I therefore don't know the measure of arc FG. So I need a way of finding CG. And there's where this 25 degrees comes into play, because angle D has two secants coming from it, right? DB is a secant, DE is a secant, and I can use that information to find arc CG. I should think about this. We'll call this, I'll just call it arc CG for now. So we'll say that we know that 25 equals 1/2 the big arc, the large arc that is subtended by angle D, minus the small arc. So I make this 50 equals, I'll just multiply both sides by 2. And if you just subtract, you're going to get M, the measure of this arc is 20 degrees. So now that we know that this is 20 degrees, we know that the whole arc FG is 100 degrees, right? So y is going to be 1/2 the arc FG, which is 1/2 of 100, or 50 degrees. And then lastly, z. Well, z, we're going to use the fact that all these add up to 360. So we do 360 minus 70 minus 60 minus 100. And that looks like it's going to be 360 minus 160 is 200, minus 70 is 130. Okay. So now we're going to move on to a challenging problem. These are the kind of problems that I love. And when I see problems like this, I love, this is like, let's have fun with it. So I'm going to add up all these. They all add up to 360, right? All these add up to 360. So that's my first step. When I see arcs, I say, hey, this is 140, this is 60 here, this is 40, this is 50. I'd love to be able to figure out this arc and this arc, because then I could figure everything else out, right? So how do I go about doing that? The first thing we see is that angle, this is a diameter here, right? So if this is a diameter, that means this whole arc that I'm kind of outlining here must be 180. If this part's 140, that means this here is 40. Now let's do the other side. We have 50, 40, that's 90, 60. So if I have 90 and 60, that's 150. This little guy here must be 30 degrees. Okay, that's great. So now from here, since we knew that was a diameter, we know that's splitting in half, we can now figure out some of these angles. Angle 1 is an inscribed angle, and the arc that it subtends is 40 degrees. So therefore, angle 1 must be what? 20, because it's a half of that angle. That's it's half of the measure of the arc that it subtends. Okay, what about angle 2? Same rule, folks. Okay, now 3 looks like it's going to be slightly more challenging, right? Well, 3, we have this arc here Angle 3 is right here. It's in this corner. It's outside the circle. So we have 3 making subtending arc 30 degrees here and 140 there. So therefore, angle 3 must be 1/2 140 minus 30. I think that's 55 degrees. Okay, let's keep going on to measure 4. Well, oh, 4. Wow, look at this. Angle 4 has 2 arcs here. It's getting a little crowded, so I'm going to erase these letters there. So we have here angle, this is angle 4 subtending that arc, and then I have to go from here over to here. So subtending that arc. So angle 4 here is subtending this angle, which is 90 degrees, and it's also doing this angle, this arc, sorry, of 90 degrees, this arc of 90 degrees. Angle 4 is on the inside, so it's 1/2 of 90 plus 90, which is 1/2 of 80, which is also 90 degrees. It kind of looks like it could be a right angle, right, folks? So that's believable. Angle 5. Actually, we shouldn't believe our eyes, right? So let's not trust our eyes too much. Angle 5. Well, angle 5. That's not looking like it's going to be too fun. Why? Why is it not going to be too fun? Because it's an inscribed angle, but it doesn't go all the way across, right? This radius here doesn't go all the way across. It's not a full chord. So what are we going to do? Well, we don't have an ability quickly to figure that out. We may need to delay this one. Maybe we'll wait on this one and come back to it, because we're going to see pretty quickly how we can get there once we get some other angles. So let's figure out some other angles first. Let's figure out angle 6. Well, angle 6 is this angle here, but it also doesn't have another arc. Oh, that one's not going to be that much easier. Well, why don't we move on to angle 7 then? Because 7 looks like it's pretty easy, right? Look at 7. 7 has this arc that goes from here all the way over to here, right? All the way over to here. So if I know that this is 40 plus 30 plus 60, it looks like it's a total of 130. Angle 7 must be 1/2 of 130. Right, angle 7 is 1/2 of 130. And that makes sense because it is an inscribed angle too. And let's move on. Let's see, can we do 8? Well, 8 I think we can do, right? 8 I think we can do, because I think what we have here is these two arcs, right? Angle 8 makes this arc right here all the way down to here, and it makes this arc right here. So 8 has 140 and 90 as the two arcs that it subtends. So I think that's 115. For 9, oh, 9's not too bad, right? That angle, that arc, sorry, is 90 degrees, so 1/2 of that is 45. And 10 looks like a central angle because it's point O is the center, so if point O is the center, 10 is the central angle, so therefore add up 60 plus 30 plus 90, and I get 130. All right, now let's see if we can go back and tackle 5 and 6. Well, I don't know if you folks can see this too, but for me, if I now know angle 10, and I know angle 2, I think angle 5 is just the third angle in that triangle. So if angle 10 is 130 and angle 2 is 25, I can say that angle 5 must be 180 minus the sum of those two angles, which was what, 130 plus 25. I think that's 155. So I'm thinking that's going to be 25. Now, what about angle 6? Well, angle 6 doesn't have a quick triangle, right? I don't have quick labels here for me to find. But maybe if I know that this here, remember how we found 4 was 90 degrees, folks? Remember we found 4 was 90? So if we know this was 90, that means we know this is 90. And remember the third angle, the exterior angle of a triangle. If angle 6 is the exterior angle, this angle right here, angle 6 must be the sum of the two other interior angles of the triangle. So 6 must be 90 plus 5. I think that's going to be 115. These are challenge problems, folks. That's why we're doing them, right? This is a challenge problem. Hopefully, of those 10, you were able to get at least 6 of them, and now you've seen at least the other 4, so that you're ready for problems like this in the future.